Hello, everybody. Good morning. From Boll Engineering. I'm really happy that so many people are here joining our session, the Palo Alto Network Troubleshooting Introduction. Pretty happy to be at least online in contact with so many people again. For those who do not know me, I'm Sylvia Schlaphof from Boll Engineering, working in the engineering department, working with Palo Alto Network Firewalls for some years already, also being a trainer for the Palo Alto Network Troubleshooting trainings, the PAN Edu 330. And I'm not alone. I'm really happy that my colleague, Peter, is also here. Peter, do you want to say hello?
Hello, everyone. My name is Michael Peter, also from Boll in the systems engineering team. I'm as well a trainer for the Edu 210 training. It's the first training you can attend with the basics, and afterwards, if you want, you can attend the 330 for the troubleshooting. So I'm here for your questions, and if you have any, feel free to ask a question in the chat or use the question and answer panel, and I'm happy to assist Sylvia in this training.
Yeah, that's great. Thanks so much, Michael. Really happy that I'm not alone here. Yes, so what do we want to do today? So let me share the screen again. Okay, so what we want to do today is having only a small look into the troubleshooting of Palo Alto Network Firewalls, because troubleshooting, I think, is one of the essential tasks we all have to do. Configuring a firewall is the one hand, but if something is not working, troubleshooting comes in place. And therefore, it's really important that we are able to know how to troubleshooting stuff on the Palo Alto Network Firewalls. As we do not have so much time, it's only a small introduction on one specific topic. I really think it's really important. So as you know, we have the 3-day troubleshooting course in place here in our training center, where we can talk about a lot of different problems that can occur. But as we know, 3 days is a lot of time, and anybody of us really has a lot of work already. That's why we wanted to have a small introduction, at least, to give you some advice or some tools that we are using in our work here at Boll Engineering. If we are supporting partners of us, resellers, that we are using those tools, troubleshooting tools that we are using very often. So once again, a warm welcome from our side, Michael, Peter, and Sylvia. We will host you on this session. And as Michael said, if you have any questions, just fill in the Q&A or the chat, or if it's a little bit more difficult, just raise your hand and we can try to open your mic so that you can ask directly. The session is in English, as we do have participants from the French-speaking part also in the session. So a really warm welcome to you as well. I'm happy that you are there as well. Okay, so let's start to not waste more time in chit-chat. Let's start with our agenda. So if I'm going to troubleshoot, one of my advices I really have is use the WebUI, or on the other hand, start with high-level troubleshooting. So that's why we start with the WebUI, very short. I'm pretty sure all of you know about this stuff you can do in the WebUI, but just to give you a small introduction again, what we have, which advantages the WebUI or the high-level troubleshooting gives us, I just wanted to focus on this one first. So then what I would like to concentrate in this session is one specific problem we have on firewalls most of the times. And what I'm talking about is the session troubleshooting. Very often we are getting support calls with the question, hey, the traffic is blocked by the firewall. We have productive traffic from internal to external or whatever, and it's blocked by the firewall. So that the session is not going through the firewall as expected. And that's what I would like to concentrate in this session. So one of the very important tools for session troubleshooting is the packet capturing. So this is the main topic here in our session. And it's an important topic because the packet capturing on Palo Alto Network firewalls are working, at least from my experiences, a little bit differently than the packet capturing on other products or like TCP dump or whatever tools you are knowing. So I will talk especially about this one. And once we have done this, I just want to give you an introduction to the basic flow logic of the firewall. So how is Palo Alto Network Firewall handling a new session or an existing session? This is really interesting to understand how sessions are handled internally. And this is necessary for troubleshooting then. And I want to show you another great tool I'm using really often, especially if I have a session that is really dropped by the firewall and I do not understand why. I will show you the basic flow log, and so that we can understand why a packet is dropped internally. And that's the second one. So that's what we have planned to do for today. And I hope that this one will be a little bit interesting for you. Okay, so if everything is okay, no questions there, no questions up to now. Okay, of course we didn't start. Yes. Okay, so then we can start. So let's start with the WebUI for troubleshooting. So why is this important for me? This is very important for me because very often we get support calls which said, hey, something is not working, let me show. And then the people are already going to the CLI and doing some deep dive troubleshooting on any problem. But without really understanding what the problem is, without narrowing down the problem, the CLI is really mindful. There's a lot of stuff to do in the CLI, but if you do not know what you're looking for, then the CLI is a little bit too much. So first of all, we need to understand the problem better to know how to troubleshoot in the CLI. And that's what's very important for me. Start with a high level, really understand what the problem is. And if you know what the problem is, then you can dig down into the CLI and just focus on this problem. So what I, for example, mean, somebody is calling. So of course, nobody of you is doing this, but just as an example, somebody is calling, oh, the internet is not working. Okay, so if I go with this problem, with this description of a problem into the CLI, the internet is not working. Yeah, so what to do there? So first of all, I think we need to understand, okay, the internet is not working. So something is not working in our environment. Maybe it's the routing, maybe it's the networking, maybe it's a firewall, maybe it's a network address translation. There are so many options for the internet is not working, so that we should narrow down this problem a little bit. And the WebUI can be very helpful for this. So that's why I want to go to the WebUI with you just shortly, because yes, you know all this stuff, but just to have a small recap on this thing. So how can the WebUI help us for troubleshooting? Of course, it's a high-level troubleshooting. And what you can do is, of course, having a look at the dashboard. And I'm pretty sure that you know that the dashboard is customizable, right? So you have different widgets and just use the widgets on your firewall which are important for you. So maybe, or not maybe, if you have HA, high availability in place, please open the HA widget here, because here you will see what's the status of your cluster right now, or the interfaces, are they online or not? Or some important logs. Maybe some logs are important for you, others not. So if you have no data filtering here, like this one here, the data logs, you can just delete it if it's not necessary. If you're the only you're the only admin on your firewall, you do not need to know the logged in admins, but if there are several just have a widget which says, okay, is there any other admin already logged in right now? So these are some really important things. And you can choose the things that are important for you and just customize your dashboard. Okay, so that's the first thing. All of you know the ACC. ACC for troubleshooting is a little bit different, but the ACC, as you know, is a graphical visualization on the traffic which is running on your firewall right now. Might be helpful if there are some, how do you say, some specific situations. So if normally the ACC widgets are looking more or less the same on each firewall. So you get to know how your firewall, how your ACCs are looking on your firewall. But if there's a specific situation, then something is wrong in the picture. So maybe like having those graphs here, if there's one line going up is peaking, then you know something is strange here. So this is something I often use just to have to have a feeling, is everything working as normal or not? Okay, so the ACC. For troubleshooting, the most important thing, in my opinion, is the monitor tab. So here's already a filter. Why? Because you have logs. And logs are so important for troubleshooting. If somebody calls me, the internet is not working, and I'm asking him, hey, what is the log saying, especially the traffic log? Oh, I do not know, I haven't looked at this. Hello? So have a look in the traffic log, because here you see if there are sessions. But you have to understand how the traffic log on the firewall is working. So with Palo Alto Networks, by default, if you haven't configured anything else, in the traffic log, you will see the sessions that already have ended. Only the sessions that have already finished, that are ended. So not the sessions that are running right now, by default. You can change this, you can log a session at session start, but by default, the session is logged at session end. So don't open a remote desktop connection and expect the session immediately in this traffic log. You won't see it. You will see it when it has ended, but not before. So that are the traffic logs. There are the other logs for the security profiles. And just to mention this one, you have the unified log, right? If you know traffic is blocked by the firewall, but you're not sure if it's blocked by the thread filtering, the URL filtering, just have a look in the unified log and search for the traffic, because here all the different log types are merged together. So only one big log file. Okay, so just come back from the traffic log. Here you will see the sessions that have already finished. If you want to see the sessions that are running right now, there's another tool, the session browser. So don't forget the session browser. Here you will see the sessions that are up and running right now. Once they are finished and the firewall policy says, okay, this session should be logged, then you will see this session in the traffic log. Okay, perfect. Yes, that are the main things here on the monitor tab. Let's go ahead. Policy tab, useful for troubleshooting as well, especially, for example, if you want to understand which traffic is matching which policy rule, which security rule. You have a test policy match. This test policy match here, you can describe a specific traffic, and then you will see which rule is used for this traffic. This can be very helpful as well. And additionally, you have some more information here. You have a hit count. So for example, of course, those are not enabled. Here's a rule which is not used at all. So if you expect traffic should use, or session should use this rule, and you have a hit count 0, you know it's not matched for any reason. So maybe the order of the rule is wrong and so on. You see the last hit, the first hit of the rule, so some more information here. Another thing which is important, please always remember that by default, the intrazone and interzone rule are not logging. So if a session is dropped by the interzone default rule, you won't see this in the traffic log. But you can, and I think I've already done this, you can override the log settings on those default rules. So by overriding them, you can enable the logging, and this might be helpful as well. So just click on it. And here already we have overwritten this log setting, log at session end. So if you do not have this log setting, no logs for those sessions that are blocked by this rule. Okay. Yeah, so even though this is important, there are some other things that might be helpful. So one I really love, let's go on to the network. We have the network here and the virtual routers. Here you can configure your static routes, your dynamic routing protocols like OSPF, BGP, and so on. Just click on the blue name. Everything which is blue on the Palo Alto Network WebUI, you can click on it. And so if you want to configure this virtual router, click on the name. But if you go to the right, we have some runtime statistics here, and it's blue as well, which means you can click on it. So, okay, let's click on it. And what we are going to see here is the current routing table. So together with all the configurations from the static route, the BGP configuration, and so on, we see the runtime statistic in this context means we will see the routing table. So we can understand just from the WebUI. We will see this in the CLI as well, of course, but you do not have to go to the CLI. You already see it here that you have a static route, which is active, which is the flags here. A is active, S is static route, a default gateway on this next top. You have some directly connected networks and so on. So this is really helpful. The WebUI does not only show the configuration, but also some runtime parameters, for example, the routing table. Okay. So, and last but not least, we have the device. Here closing this one. Here we have a lot of other helpful tools. So one tool I really love, just for you to remember, is the config audit tool. With the config audit tool, you can compare different configurations you have committed on the firewall. And so, for example, everything was running well, and then your colleague yesterday evening changed the configuration. You just know he has changed the configuration yesterday evening, and on the next morning, when you came back into the office, some people complained that some stuff is not working anymore since this new configuration change from your colleague on the day before. As you might not know what he has changed, you just can check it with the config audit tool. So you can go to the local running config and maybe check it with the version which is committed maybe yesterday or the day before. I just take one later on, just to have some information here. So what we can do right now is just choose the different configs we have on the disk of the Palo Alto Network Firewall, click on Go, and then those configs will be compared, and you will see the differences here. The green is what have been added, the red is what have been deleted, and yellow is what have changed. So you will see the changes in the config, and you will see the context of 5 lines. So this is the 5 here. So you will see the 5 lines before and after the changed config part. So you can go and, okay, link state down and so on. Next top has been added, has been changed, some stuff has been changed and so on. So this might be very helpful if you want to understand what has changed. Somebody complains, yesterday it has worked, now it's not working anymore. You know that there was a config change, but you do not know exactly what has changed. Just use the config audit tool. Okay. This is this menu. Another one which I really like, of course, is the troubleshooting. We are talking about troubleshooting. We have a menu which is called troubleshooting. In here, of course, are some troubleshooting tools. Those tools are all in the CLI as well. But again, if you do not want to go down to the CLI, you have a lot of tools already here. So for example, the policy matches. There are different policies on the firewall: security policy, QoS policy, authentication policy, and you can use the match tool. So if you want to understand which NAT policy rule is matching specific traffic, just describe the traffic here. If it's coming from a specific zone to a specific zone, specific source IP destination, and then you will see the test result, which NAT policy rule is nutting this traffic. So this might be very helpful. And of course, there are other tools, routing tools, if we want to know how a specific IP is routed, for example, this one, blah, 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 with this virtual router, execute. Execute. This is live, huh? This is, so now we can execute, of course. The forward information base, I was looking, okay, test result is there, I can click on it, and then I will see the test result. It's going to my, it seems, to my default gateway here, of course, it's internet web. Okay, so there are some rules you can use even without going to the CLI. You can ping, you can do a trace route, you can check external dynamic lists and your update server connectivity, all this stuff. So don't forget that you have this tool in the WebUI as well. Of course, if you prefer to go to the CLI for doing those things, it's okay as well. Just wanted to mention this, that you do not have to do this. And last but not least, the last one, which might be important, especially if you're troubleshooting by yourself and do not find the solution and you want to open a ticket with your ASC or with Palo Alto Networks, they really love it if you send them the tech support file. The tech support file can be generated here. It's a big file. The firewall will combine a lot of internal logs, configurations, state, CLI commands into this tech support file. And for the supporting guy, it's really helpful to have this file because he do not have to ask for every specific CLI command because everything is, most of the stuff is already in this tech support file. Just generate it. Once it's generated, you can download it here and you can send it to, you can append it to your ticket, and this would be very helpful. Okay. Yes. This has been some stuff. I just want to remember you that you remember this, that this might be helpful for troubleshooting. But I'm pretty sure most of you already know this stuff. So let's do some more deep dive.
Maybe we have one question from Tom. He asked if the session browser also shows session in discard state. Maybe you know that. Otherwise, you have to check.
It depends on. So I'm not 100% sure, but I would say if the session has been opened and then, for example, the security rule like AV or something kicked in and the already existing session in the session table needs to be blocked because firewall found the virus, I think then we will see this session in the session browser. If a session, on the other hand, doesn't come up in the session setup and will be blocked already in the session setup, and I will talk about the session setup later on, then I'm pretty sure that you are not seeing the session in the session browser. So I would say it depends on when the session will be blocked or discarded. Right in the beginning, you do not see the session in the session browser. Later on, after the session runs for a while, and then is blocked by AV or application control, whatever, then you will see it, I would say. But I have to double check this, to be honest. I'm not sure about this, but that's what I would guess. Okay, hopefully this helped already. Okay, cool. Any more questions?
No.
Perfect. Thanks, Michi. Okay, so let's go further. So one of the situations we have in support when I'm on the support phone or one of my colleagues is at the support phone, that we get a call, yeah, you know, something is not working, so the firewall must be the problem. I'm pretty sure most of you know this. So if something is not working in the network, first of all, the people think it's the firewall. The reason is the firewall. Okay, I can understand because the firewall is made for dropping and blocking some traffic. But on the other hand, it does not mean that if packets or sessions are dropped, that is always the firewall. But anyway, the people think so. And so it's our job to understand or to find out if it's really a problem of a firewall. So, and this is why I love the packet capturing tool on the firewall. Why I love this tool really hard, because let's make an example. Let's have a client here in your internal network, and he wants to browse the internet. So it's not working. So somebody is calling you, yeah, the firewall is dropping this traffic. So what you can do with the packet capture right now is you can start the packet capture and see or find out if you see the request from the client. So do we see incoming traffic? Because if we do not see any incoming traffic on your firewall, of course, I understand that the traffic is not working, but then it's not the reason, or the reason is not the firewall. Maybe the client has a wrong default gateway, or maybe the client is not connected to the network at all, something like this, or maybe there's another problem. But if you do not see incoming traffic with the packet capture, you might understand, okay, it's not the firewall. Or on the other hand, let's say you see the incoming traffic and the traffic is sent to the server, but you do not get an answer. Of course, the client says it's not working. But in this case, if everything is good with the firewall, so if the traffic is sent out to the right gateway and network address translation is in place if necessary and so on, if everything has been done correctly by the firewall and the server is not answering, you have a proof that it's not the firewall. So I do not want to get rid of all the problems, but I just want the people to understand it's the firewall who's dropping the traffic or somebody else. So that's important to understand before we do a deep dive into the firewall troubleshooting. So let's say the server is getting the traffic and it's answering the traffic. Okay, then we have to make sure that the answer from the server is forwarded to the client. Okay, so this is how it should look like. If it's not looking like this, who is dropping the traffic? You can understand this with a packet capturer by capturing the traffic. If you see the traffic incoming, but not outgoing out of the firewall, we know, okay, the firewall is dropping the traffic. If we see the traffic incoming and outgoing, but no answer coming back from the server, we understand, okay, it's maybe the server who's not reachable or down or something else, and so on. So this is really important, and this is working for the other direction as well. So if you have a server which should be reachable by a client, then the external client says it's not reachable, just do a packet capture. Is the request from the client arriving at the firewall? If yes, have a look if it's forwarded. If it's forwarded, okay, it's up to now, it's not the firewall. Is the server answering? If not, we have to look at the server. Why is the server not answering? If the server is answering, will we on the firewall forward the answer to the client again or not? These are the magic steps that you can troubleshoot with a packet capture. So because the packet capturing is so important, at least in my opinion, for answering this first question, we need to know how the packet capturing on the firewall is working. And that's what we are doing today. Okay, so before we start, we have to have to understand one thing first. If you want to capture traffic on the firewall, you have to decide, do you want to capture management traffic, which arrives on the management interface? Or do you want to capture traffic on the data interfaces? So like internet traffic, which is processed by the firewall. You know, the Palo Alto Networks firewall is built up out of with the control plane for the management traffic. The management interface is connected here. And for the data, we have the data plane with the data interfaces for processing the productive or transit traffic, how we are calling this transit traffic, which arrives at the firewall and leaves the firewall. This is transit traffic. This is handled by the data interfaces from the data plane. So what I wanted to say is, if you are looking for capturing management traffic on the management interface, you have to use TCP dump on the CLI of the firewall. There's no other tool on the firewall to capture this management traffic. On the other hand, if you want to capture the transit traffic, and that's what we are talking about most of the time, you have two possibilities. You can use the packet capturing in the WebUI of the Palo Alto Network Firewall, or you can use the packet capturing on the CLI, which is the same, but this is a specific packet capturing. It's not the TCP dump. With the TCP dump, you can only capture the management traffic or the traffic on the management interface. Transit traffic needs to be captured by the WebUI packet capturing tool, or if you prefer to do it in the CLI, you can do this in the CLI as well. I prefer to do this in the WebUI, and that's why I want to show you the WebUI mainly. So let's have a look at the WebUI. If you go to Monitor in the WebUI and click on Packet Capturing here, you will find the packet capturing. So this is what I didn't show you in the beginning when I show you the log, but this is a really important tool for capturing the packets. So there are 4 steps if you want to use this tool. First of all, you should configure filters, of course. If you're capturing all of the traffic running through the data plane, I'm not sure if your data plane is very happy about this, and your management plane as well, because you're adding a lot of resources to the firewall, to the data plane and the management plane. So make sure that you are filtering only this traffic which is of interest, or only the traffic you wanted to see. So not only because of the high load of the firewall, but if you have a really, if you're capturing everything and you get a really big PCAP file, you didn't find the packet you're looking for. So have good filters in place, and we will talk about the filters later on. Second step, you have to define stages. And the stages are really special. And that's why I'm really focusing on this tool, because packet capturing on the Palo Alto Networks firewalls is working a little bit different of other packet capturing tools you might know from other devices or from Wireshark or TCP dump, because we have those stages, and I will talk about the stages later on as well. So once you have configured the filters and the stages, then you can start the packet capturing here. You can enable it, then run the test traffic you're looking for, and then turn off the packet capturing again, and you will find the results of the packet capturing already in PCAP files here on the right side of your screen. You might have to refresh the screen, but then you will find the PCAP files, and you can just click on them, open them in Wireshark, and you will see the results. It's really, really nice. Okay, so let's start with the filters, going to the details. If you click on filters, Manage filter is blue. You can click on it again. The packet capture filtering screen is opening. So what you can do here is you can add up to 4 different filters. 4 filters, not more. You can add 4 filters, and every filter consists on an ingress interface, a source IP, a destination IP, source destination port, a protocol number. 6 is TCP, as you know. And you can decide if you want to include non-IP or exclude non-IP traffic, and if you want to add IPv6 traffic as well. Okay, so whatever you are configuring within one filter, so within one line, is a match criteria which is connected with a logical end. So the first line says, if you have a packet with 192.168.1.20 source address and 50.10 destination address and the destination port 80 and the protocol TCP/6. Or, and this is, now we are getting to the second filter. The second filter is a logical, combined with the first filter with the logical OR. So you have 2 filters. So the packet must match the first one or the second one. And this is how it works with all 4 filters. If you have 4 filters in place, then the packet can match the first one or the second one or the third one. But within one filter, you have a logical end. If something is empty, like here, which this means any. So no matter which the source port is, only the destination port needs to be 80. Okay. Yeah, these are the filters. And
question, Sylvia,
yes,
if you want to check that from Tom.
Yes, he is right. Tom is right. You already worked with this, Tom. Huh? Tom said, as far as I know, you do not need to specify the reverse traffic in the filter for TCP session. It's included automatically. Yes and no. And I will come to this because this is one of the important things. And that's a good question. Because this is important to create the right filters, because if your filter is not matching your traffic, you do not see it, and this would give you a wrong result. Okay, thank you for this one. Before I get to the filtering, I want to introduce the stages as well, because they are really important. So they are important because they are special on the firewall. This one here looks really difficult, but it's not. So let's try to understand what we want to say here. So first of all, if we are capturing packets on the firewall, we can capture them on 4 different stages. We have the receive stage, the firewall stage, the transmit stage, and the drop stage. What does this mean? So it's like having a big room with 4 different cameras. So we have one camera which shows which people come inside into the room. So this is the receive stage. If the packet arrives at the firewall, no matter on which interface, and that's the specific thing. If a packet arrives at the firewall, no matter which interface, it will be captured by the receive stage. Then the packet is processed by the firewall. This is captured by the firewall stage. If the packet has been processed by the firewall and is forwarded or is sent to the egress interface, so if the packet is leaving the firewall, then we can capture it with the transmit stage. If one of the stages, for any reason, is dropping the packet, then there is a specific stage or a camera which is capturing all the packets that are dropped. It's like having a camera on your waste Abfalleimer?
Waste bin.
Waste bin. So if the firewall is sending a packet into the waste bin, then you have a camera which is capturing the packets which are thrown into the waste bin. You know what I mean, right? So, and without any filter, it doesn't make, if you're not filtering on a specific interface, the receive stage is capturing traffic on all the different interfaces. So you have a receive, you receive packet on one interface and the other, and the receive stage is capturing them into the same file. And this is something which is strange, and this is what we want to explain. So let's make an example to make sure what I mean. So let's make this an example, and we will do the capturing on this example later on. So let's say we have a client with the internal 120 and the server. This is a DMZ server because it's a private IP address here, but just want to show how it is working. So it doesn't matter if this is a private IP. So this is a destination IP. So let's say it's a web server. I connect from the client to this web server. What is happening is, of course, the first packet, it's a SYN packet, arrives at the firewall with the normal IP addresses, the source IP and the destination IP. So if you capture on the receive stage, you will see this packet here on this receiving interface. This SYN packet is then transmitted to this interface. And if it's sending out to the web server here on the outgoing interface, then the transmit stage is capturing this packet. The same packet is first captured by the SYN stage and by the receive stage. I did not mention the firewall stage in between because I just want to focus on those 2 stages. And the same packet is captured by the transmit stage as well. So now the reply traffic, the SYN acknowledge, is received on this outgoing interface, or now it's the incoming interface from a packet perspective. So now it's the receive stage which is capturing this packet, and the transmit stage which is capturing the outgoing SYN acknowledge, and so on. So what I wanted to say is that the receive stage can capture traffic on different interfaces. and also the transmit stage. So it is not that we are capturing traffic on one interface, like other packet capturers from other vendors, or like Wireshark. There you can say on Wireshark, I want to capture the traffic on one specific interface. That's not how it is working here. Here we are capturing per stage, per capture stage. Okay. So this is the theory. Yeah, I think it's good to have an example for this. So let's go to our packet capturing here. Packet capturing. Click on the filters. It's pretty empty here, but I will start with one filter, which is matching the IP addresses we had in our example. Okay. Okay. And as Tom already mentioned, normally we do not need to have a filter for the return traffic, because as you see here, the return traffic, the traffic from the server to the client, the source IP is what has been the destination IP in the other direction. Of course, it's the other way around. So as Tom said, we do not need to add the reverse. So let's start with this traffic only, with this filter only, just to make sure that this is working as Tom already mentioned. Now we have to add the different stages. So I have a stage, receive stage. I want to use the filter and the file xpcap. Okay. And now we have to work a little bit to add the next one. So let's have the firewall stage, writing the captured packets into this file, having the transmit stage. So I will start very, very easy, having one file per stage. And we will change this later on. And having, last but not least, the drop stage. Okay, with the file drop. Okay. Okay, perfect. So now we have 4 stages. We have our filter in place. Make sure that the filtering is on. If the filtering is off, you can configure whatever filters you want. They are not working because they are not enabled. So please make sure that they are enabled. Now the second step was to configure the stages. Now we can start the capturing. Okay, it's getting a warning. Hey, it's only for troubleshooting. This will take some resources for your data plane and management plane, because the data plane is capturing, the management plane is saving the files. And so we should hurry a little bit, normally on a productive firewall. Now, I'm going to test.lab because this is my 192.168.50.10 server. I will do this just to make sure with HTTP. So it's just for testing. Bam, bam, we have our website. That's perfect. So now the traffic, this was traffic running through the firewall. And if I'm lucky, if my filters were correct, I should see the result, refreshing the site. I should see the result here. Now we have the captured files and we can just click on them, open them. And now we see the receive stage. So we see the SYN packet arriving at the firewall. We see the SYN acknowledge arriving at the firewall, the acknowledge, so the three-way handshake, which has arrived on the firewall, the GET request and the website and so on. Perfect. That's what we wanted to see. The same packets have been captured by the firewall stage, where the packets have been processed. Everything runs well, that's why we see all the packets here. And everything runs well for the transmit stage as well. If we click on the transmit, we will see the packets here also. So everything is nice, pretty easy, right? No brainer. Yes. Everything runs without problem because we do not have any network address translation in place. Right now, there was no address translation. But normally, if we have internet traffic running to the internet or coming from the internet, whatever, in most of the times we have network address translation. And this has a big impact on our traffic. Why? That's pretty easy. So let's say we add source NAT. doing a translation on the source address. So in our example, this doesn't make sense at all, but just to show you that it is how it is working. Let's assume that we add, or we can already do this, so we will do not waste time. Let's go to the policies, to the NAT policy. I already have a source NAT rule in place, source NAT to DMZ. I will enable this rule. And this rule will do a source NAT on all the traffic running from inside to DMZ on this new source IP. This is the new translated source IP 172.60.60.60. I'm committing this, and in the meantime, while this committing is running, normally we are all grabbing some coffee when the commit starts because it takes some time. Same for me, but in the meantime, during the commit will run, we can just have a look how the packets are running through the firewall now. So have the same, we are having the same example, but now with network address translation on the source address in place. So the same packet arrives, and what is happening when the packet is transmitted, of course, the source address is translated to the 172.60.60.60. So this is what we see on the transmit stage, the new source address. And also the SYN acknowledge, which arrives from the server, arrives to the NAT IP. So the destination address is now the NATed source IP from the SYN packet. On the receive stage, we have the receive stage here and here. So if we go further, this packet, the SYN acknowledge, is transmitted on transmit stage, but now without the NAT address, of course. Now the NAT has been reversed and we see the original traffic again. And this is what is happening to our packet filter as well. And there's something pretty strange. So commit is ready. So let's do the same packet capturing again, right? Right, so let's go to monitor. Have a look at the filter again. We still have this filter in place and you already know what's happening right now. I'm going to delete those old files because if I'm not deleting them, the new captured traffic will be appended to the existing files. And then we are getting a little bit confused because we see the old and the new sessions. So I'm deleting them, starting the packet capturing again. Okay, that's fine. Going to my browser, this is my client. Doing a reload. So a new session has been done. You didn't see this, but in the background, the session runs through the firewall. So disabling packet capturing, refreshing the screen. Now we see traffic. So now it's getting interesting. Let's have a look at receive stage. At receive stage, we see everything, right? SYN acknowledge, the GET request, and so on. But if you have a closer look at the IP addresses, the first SYN at receive stage is on 120 to the server, but the SYN acknowledge is matched to the, of course. This is what we have seen here. Huh? This is the SYN acknowledge we see on the external interface with the NATed address, because we received the packet and there we see the original IPs from the packet, and these are the NATed, this is the NATed address. So the problem is if I'm going to do, for example, a follow TCP stream here, we just see half of this, half of the session, because of course, Wireshark doesn't understand that the rest of the packets belongs to the same session, but they are different IP addresses. So this is a little bit a problem. Anyway, let's have a look at the transmit stage. Wow, there's no filter in place, but on transmit stage, we do not see, for example, this SYN packet here. This is transmitted here, but we do not see it here on transmit stage. And this is something which is really strange, but this is how Palo Alto Networks packet capturing is working. On receive stage, the firewall is able to understand that a filter which is configured, is matching not only those IP addresses, but also the NATed IP addresses. So you remember we have seen the packet with the 172.60.60.60 address here, even though there's no filter for this one. So because this is because the receive stage can understand this. This belongs to the same session. It's not the same IP, it's NATed, but the receive stage will capture the NATed packet also. But the firewall stage, the drop and transmit stage, they do not understand this. And this is the reason why, oops, sorry, I have to look to the Wireshark. Why in transmit stage here, we only see those transmitted packets which are matching the filter in original direction, or as Tom already said, in reverse direction as well. So even though we had this transmitted packet, it's not filtered. What do we have to do? Any suggestions? Who knows what we can do to overcome this problem? Anyone? Oh, there's another really good question, which I will explain. So we will wait. Maybe somebody has a suggestion what we can do. Manuela is mentioning another topic. Manuela is mentioning the offloaded traffic. This is really important. If traffic is going to be offloaded by the network processor, if you have a firewall with a network processor, a model with a network processor, and the session is offloaded, we do not see this packet in the packet capturing. But the problem we normally have in session, if we have session problems, it's the session setup we are looking for, and the session setup is never offloaded. Or we have problem with some security profile, something like this, and they are not offloaded as well. So this is good for us because we do not have to disable the offloading most of the time for seeing the interesting packets in the packet capturing, but we just have to take care or just have in mind that offloaded packets are not captured. Okay. Okay, cool. And so get back to our problem. We want to see the transmit packet on the NAT addresses as well. And it's pretty easy how to solve the problem. We just have to add a second filter with the NAT address. So we can do this in original direction. That means we can do this in this direction. Or we can do this the other way around. As we have learned, it doesn't matter because the firewall is matching the original packet and the reverse packet as well. So it doesn't matter if we do it like this or if we switch IP addresses, source and destination and ports here as well with those two IP addresses, doesn't matter for us. Okay, so having this filter in place, filter for the packet with source NAT and without source NAT, doing a packet capturing again. Yes, I'm deleting them. And now starting the capture again. Okay. And refresh the session. Perfect. Now having a refresh on our files. Ta-da! I already see that's better now because the size of all three files now is the same. So receive stage didn't change. We have all the packets with the source NAT and the NATed. We have seen this before. Now both filters are matching this traffic, so no change here. But, sorry, having a look at transmit stage, here we will see both packets as well now too. So we see the first transmitted SYN package, which already has this NATed IP address. This is the second filter we have added. And then the SYN acknowledge with the original one. So now we overcome the problem that in transmit stage, we only see half of the packets because the filter haven't matched the NAT, the source NAT address. But we still have a problem, right? We still have the problem that we do not see the whole session. So what we are seeing right now in transmit stage is the syntax, the dark blue. So we see the transmitted packets in this direction on the outgoing interface, on the DMZ interface, and the packets from the server to the client on the other interface. So it's more or less some different packets because they have different IP addresses. This is the outgoing part, this is the incoming part. So it's a little bit strange. So how can we see what is communicated from the client to the firewall as one session? And how can we see this session, what is communicated from the firewall to the server? So I want to see this session here and this session here. But they are split up into receive and transmit stage. And there's a cool trick how we can do this. And the trick is pretty simple. By just having the receive and transmit stage, logging the packets into the same file, right? Okay, let's try this. Let's go to transmit stage and change to a file called rxtx. rxtx, okay. And now make sure that on receive stage, you use the same file name. So both stages are capturing the packets into the same file. Ta-da, okay. Let's have the, again, receive side. Oops. Oh, we are still, that's not good in production. Always make sure that you're turning off the packet capturing, as I didn't right now, because this takes resources on your file. Okay, so now we are starting this using the same filter. Everything is the same. Having a browser refresh, bam, bam. Going back, turning off capturing. And hopefully we will see some packets here. Wow. Now we have not a receive PCAP and a transmit PCAP, but only one file. And if we have a look into here, I'm not seeing what I'm expecting. Just what is happening? Let me check. Receive, transmit, the same name, yes. And we should see. Momo, sorry, I'm wrong. Of course we see what I'm expecting. I'm sorry. I've expected already the next example. Okay, so what we see now is two sync packets. Two? I just pressed one. Yes, of course. Now we see the same sessions twice. We see the session with the original IPs and the same session, but now with the NATed IPs. So now if I'm doing a follow TCP session stream, I will see the session from this packets here on this interface, because I'm just filtering on those IP addresses without the NAT. So I see the communication between the client and the firewall. And on the other hand, if I clear this and follow this TCP stream, I see the very same session, but now from the firewall to the server. So now you might say, yeah, is there a difference? In this example, there's no difference because we just have the difference in the IP addresses, but it's the same. But if you assume that the firewall has some security profiles in place, then yes, then we would see different stuff. And this is what I want to show you as one of the last examples. So what we are going to do now is we have a URL category, a custom URL category already pre-configured, which is matching on test.lab. So this is our web server, just for demonstration, right? And this custom category is added to a URL filtering profile. And now I'm going to my security rule And I'm going to add, this is from inside to DMZ, that's the right one. I'm going to add this URL filtering profile, test lab, block test lab, that's the right one, to my rule. So now, when I'm capturing the traffic again, I should see that the traffic is blocked. Let's see if this is correct. So the commit is done. We can already go back to the monitor. Everything, filter and stages, we are keeping the same. I'm just going to delete the existing ones to not get confused from the old example. And in the meantime, the commit is already done. Time for some coffee?
Yes, because there are no open questions. I just added the link to the documentation for the packet capture as well in the chat, so you can find it as well here.
Thanks. That's great. Okay. Cool. So commit is done. Now the URL filter should be in place. I'm going to enable the packet capturing. Okay. So now I'm doing a new session. Bam. Of course, that's what we have expected, right? Because now we have blocked the URL test.lab or www.test.lab, and we are seeing a response page from the firewall. So how does this look like on the packet capturing? Let's see our results. Dun, dun, dun. Now there's something new. So in comparison to the packet capturing before, we didn't have a drop PCAP. Now we have a drop PCAP. There are packets dropped. Oops. Okay, let's come back to this later. Just have a look here to the receive transmit PCAP stage. Yeah, here we will see some more stuff right now. Okay, so what's going on? Let's start with the first SYN packet, the original one. So the communication between client and firewall. Have a look at the follow TCP stream. What we are going to see here is the request from the client. And now the answer, of course, with the response page. This is the response page. If you can read HTML, blah, 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 the image, and here we'll see the web page blocked, right? This is what we have seen here on the Firefox browser, web page blocked. This is exactly what we are seeing. Oops, sorry. What we are seeing here in our TCP stream. What are we going to see if we filter, if we're going to filter on the external interface? So the session with the translated source address. Well, let's have a look. Have a follow TCP stream. And now we are seeing really not very much. We see the SYNs and acknowledge, and then we see a reset. What is happening here? And this is something, of course, which really makes sense. So let's have a look at our example. Let's say we have the URL filter in place. What is happening now? So first of all, the SYN packet runs through the firewall. This is what we have seen. The SYN acknowledge is answered by the server, and then the TCP handshake is completed with the last acknowledge. What is happening then is that the GET request from the client is received by the firewall. But now there's a URL filter in place, and the URL filter already kicks in because the host name, the URL, is seen with the GET request. So what the firewall now is doing, it's doing two things. First of all, it's sending the response page to the client, and it's sending the reset packet to the web server. Because without reset packet, the web server will still have the session opened here, and it needs to be timed out. So for the firewall said, no, I do not want to allow the session. Now we have seen the host name, the URL. So the firewall is resetting the already opened connection to the firewall, because we are doing flow-based inspection. So the session is already open. So we need to finish the session here. Okay. And this is exactly what we can see in the packet capturing, right? And this is really helpful sometimes to understand how is the firewall changing the session from the client to the server? And we can see it with this one. So we can see the communication between client and firewall, and we can see the communication between firewall and internet. And this is why I love the packet capturing also, just to understand what the firewalling is doing with the traffic if some security profiles kicks in or something like this. Okay, so the last thing I want to mention here is the drop stage. Why do we have dropped packet? And we see a lot of dropped packets. And this is because the firewall have to handle all these changes she's doing through the firewall filter, because the firewall is receiving the GET request. And now we have this packet with the GET request. And we are not allowed to forward the GET request to the server because we are resetting the session. So the firewall has this packet and needs to drop it. So this is what the firewall is doing. The firewall here is dropping the GET request. And we see it's the one after the firewall processing, because we already see the packet with the applied source NAT address. And the same stuff for all the other communication. So for example, the firewall is sending the response page. The response page is being acknowledged by the clients to the firewall, but of course the firewall is not allowed to forward the acknowledge to the server. So all these other packets which now occurs because of the response page or the reset acknowledge, all those packets needs to be dropped. And this is what the firewall is doing transparently. You do not see it, but the firewall has to do it. And you can monitor this with the drop stage, because here we'll see all the drop packets that the, for example, the server is sending back or the client is sending back and so on and so on. Okay, so this is why we have a lot of packets in the drop stage. Okay, cool. So this is how the tool, the packet capturing on the firewall is working.
Sylvia,
yes.
We have one raised hand. Maybe
Okay.
Lucas wants to ask something, or has it already been answered, your question? Then please take back the hands up. Otherwise, I give you the allowed to speak. Is that okay for you, Lucas? So I give you the speech allow. If you want, you can unmute yourself and ask the question.
Hello, Lucas. Nobody.
No, let me check if I can.
Now you should be able to unmute, yeah.
Maybe it's already has been answered because he.
Lower hand?
Yes.
Okay.
So let's continue.
Cool. Okay. So this gave me some time to change my configuration. Okay, I'm doing the commit. Okay. So after we have introduced this tool, now let's have a real example. So an example where some stuff is not working. And to have a good example, I just changed my configuration, and hopefully this is committing pretty soon. Yeah, now it starts. That's good. I will already change my filter. You can delete those two. I add one, a pretty easy one with Proto 1. So this is already in place. Okay, I will come back to this later, just having some preparation done. Okay, deleting this one. Okay, so now let's have a real-time problem. So I had a new configuration, and my problem now is the customer calls and said, internet is not working. And I ask him, hey, what do you mean? Yeah, I already tested a lot of stuff. I'm still not able to do a ping like this. So this is the client starting a ping to 1111. And it looks like it's not working. So now we can do some traceroute and so on, but I still want to get to the packet capturing already. So let's stop this and have a look on the filter again. I just filtering because there's no other traffic around here, just filtering on protocol 1. This is ICMP traffic. So I'm starting this, okay, and I'm doing the packet ping again. Hopefully see or do not see traffic on the packet capturing. So now my idea is, if I do not see any ping traffic in the packet capturing, I know the client is not having the right default gateway or is not getting to the firewall, right? So stop this, stop the capturing, and now see if the ping arrives at the firewall. Unfortunately, it seems something has arrived. And we already see some drop packet. Oh, that's not a good sign. So in this case, let's have a look. What do we see? We see, why is this not opening? A little bit bigger. We see a lot of ping requests, but we only see the ping request with the original source NAT IP. Okay. So now, as I have a file on receive and transmit stage, I'm not really sure if these are received packets only, but also transmitted. But as the sequences here are all different, I assume that this is only received packet. So if I would see the transmit packet, I would see the same packet twice, maybe with NAT or without NAT. Anyway, I see those packets arriving at the firewall. And if I had a look in the drop page, drop stage, why is this not opening anymore automatically? I see the same packets in the drop stage. So the firewall is dropping the pings. But is there something you are seeing, something special? You will see already NATed packets. So the NATing is done after the firewall processing. So I know that the firewall has processed the traffic, and I also see this because I see the packets in this stage, in firewall stage. So the packets are received, the packets has been processed by the firewall and later on dropped. And this is something where we already learned something. Let me show you this slide again. We have seen before. So packets can be dropped at different stages. Packets can be dropped already at receive stage, or maybe later on during firewall stage or after firewall stage. So it depends on where we see the packet on which. So let's say we see the packet only on receive stage and on drop stage. This means that the packet doesn't made it to the firewall stage. So it already has been dropped because of some tests here at the receive stage. But in our case, we have seen the ICMP packet on receive stage, on firewall stage, and then on drop stage. So the firewall stage was in place. So it's not the receive stage who has dropped the packet, but later on something at or after firewall stage. So now we are sure with the packet capturing, we are sure the firewall has dropped the packet, but we do not understand why, or maybe we do not understand why. So at least we know it's our problem. We have to take care about this. This is why the packet capturing already helped us. So now what is the next thing we can do? So first of all, maybe we should check the configuration. So maybe you are confused by the NAT address. So as we are pinging into the internet, we are using another source NAT, the source NAT, which is showing with the public IP into direction internet. That's why we have the wrong one here, but it's the right one. So I know this is my public IP address, and the packets should have been NATed to this IP address. So just to not confuse you. So now, what is the next thing we can do? So normally we have to check our configuration if everything is correct and so on. But there are situations where you think everything on your configuration is correct, but even though it doesn't work. So now, how can we go on? So the next thing we can do is using another tool, and I'm just switching to the right slide. We can go on and use another tool which describes not only which packets are seen on the different stages, but this tool, the packet flow, the basic packet flow basic log, it's a flow basic log. This is the name of the tool. This shows the packet flow within the firewall. So we know our ICMP packet is dropped somewhere within the internal processing. Now we have to follow this packet within the internal processing. And we have a tool for this. It's called the flow basic log. So to use this tool, we have to understand how the packets are processed internally. And to explain this, I will need another 1-2 hours. And this is what we are doing, for example, in our 3-day troubleshooting course in the 3:30. But I just wanted to show that this is possible. So we are doing a quick one. What is happening internally? The packet is received on the firewall, and this leads to the ingress stage from the flow basic perspective. So this is the ingress. The packet arrives at the ingress. Here, the firewall will decide if the packet belongs to an existing session in the session table, or if this is a new packet for a new session, like a SYN packet on TCP or ICMP in this case. So this is one of the decisions made on ingress stage. Is this a new session? And how the decision is made, we will explain in detail in the training, but yeah, we only have 10 minutes. So here the decision is made, is it a session, a packet belonging to a new session, or is it a packet belonging to an already existing session? Depending on this decision, the packet is forwarded to the slow path stage. The slow path stage means we need to do the session setup. It's a new session. We have to set up the new session. Or if the packet belongs to an existing session and there are no other routing decisions needs to be done, something like this, then it's going directly to the so-called fast path stage. So don't get confused. It is not the offloading, what we call the fast path stage. The fast path means that all decisions about routing, NATing, security rule are already done. This is what we call the fast path stage. Okay, so once in the security processing, the content scanning and app ID scanning kicks in and so on. We do not want to look at this right now, just the session handling, layer 3, layer 4. And if everything is correct and nothing is going to be blocked, then the packet is egressed, transmitted to the next hop, something like this. So, and this processing can be captured on the firewall with the flow basic log. This tool is a CLI tool. Now for doing this really deep dive scanning or capturing on the process flow, we need to go to the CLI. So I'm going to the CLI, just connecting, where do we have our CLI? So this is my firewall here. And because I'm a little bit lazy and I do not have so much time, I have the commands necessary for the flow logic already typed here in my text editor. So we can already talk about this one. So first of all, I'm using those two commands, copy and paste. What I'm doing here is I just, that was the wrong one. I'm just clearing everything which has been configured before. This is not very smart, I realized right now. Anyway, let's have a look at the debug data plane packet diag show setting. This shows me all the settings I have done for this packet diag right now. And I see that there's a filter enabled. I see that logging is not enabled right now. And this looks pretty good. So I need to enable the logging, but first I had to look at the filter. So the smart thing is that the same filter used for the packet capturing is used for the flow basic log. So I just cleared it with the command before. That's why I said that wasn't very smart of me. So through this Sorry, so this clear all, I have cleared by filter. So this was not so smart. So I have lost this one. So I have to reconfigure it. Was this the right one? Yes. Huh? Yeah, only protocol number 1. Okay, so go back. I'm sorry. So with this filter in place, show settings, now I see my filter again. So it's this filter. That's good. So first step of preparation, doing a pretty good filter. And here you really have to make sure that your filter is good, because the flow basic log takes even more resources than the small packet capturing, because we are capturing much more information per packet than before. Okay, so filter is in place. Now I clear the resulting log file. And this is a strange command. Some things in the CLI of Palo Alto Networks are a little bit strange. This command says debug data plane packet diag clear log. This means within the log feature, clear the log file. This is why we have a double log. So this is correct, this syntax here. Okay. So now what we are doing next is we are enabling our logging, our flow logging with this command. Oops. This one. Paste. No, sorry. Now sorry. Maybe sometimes it's easier to type. Copying. Paste. Okay. So with the show setting again, I will see that the log feature flow basic is enabled now. So log feature set to flow basic. Okay. So now the preparation steps are done. It's a little bit complicated, but you're getting used to it, I'm pretty sure. So now the next thing we can do, we can enable delogging. So copying this command. Pasting. So we say, okay, like set capture on, what we did in the WebUI before. Now we set the log feature on. So start log. This means if the command would have been correct, copied. So debug data plane packet diag set log on, which means we are starting the logging right now. Okay, we give a warning and be careful, it takes a lot of resources, it's going to be disabled automatically if the resources are overloaded, blah, blah, blah. So now let's have a ping again. Now we are capturing this ping with a flow basic log. This should be enough. So now we can disable the logging. And now the output is logged into different files on the file system on the hard disk of the firewall. So to get all the logs together, we have a command which is called aggregate logs. Copy, paste, aggregate logs. So now the logs are aggregated into one file. And this file is located on the hard disk, and you can reach it from the hard disk, for example, with the less command. And there are two directories, the mp log and the dp log. So normally you will find the file we are looking for in the dp log because it's captured on the data plane. So will be saved. Yes, it will be saved on the management plane on the hard disk, but in the directory called dplog. But as we have a virtual firewall here, we do not have a DP, a data plane. So everything is in the mplog in this case. So depending on the model, you will find the file in the mplog or in the dplog. And the file we are looking for is called punpacketdiag.log. Yes, this one. So, and now I just enlarge this. We will see the output of the flow basic. And in the first moment, it's wow, what's going on here? But it's really easy to understand. So here we will see a packet at this time state that the packet is received at ingress stage. You remember the ingress stage? This one. The packet is arrived at ingress stage. let's have a look at the packet details. We will see here the IP, the layer 3. We will see the source IP, the destination IP, and the protocol number. This is our echo request. Okay. Here we'll see the ICMP type and code. This is why I know it's the echo request, type 8, code 0. So now the result of the ingress stage, you remember the ingress stage says, okay, is this a packet for a new session or for an existing session? It said no active flow found, which means it's a packet for a new session. There is no session in our session table in the session browser. So it's a new session and we have to set up a new session. And that's why we see this exactly the same packet routed to the slow path stage. So it is really the same packet here. You will see this the same on there's an ID for the packet as well, but it's easier to see here that we have the same packet here, type 8 code 0, now received at slow path stage. And here at slow path stage, all the magic is happening, which means, okay, the security rule is matched, the NAT rule is matched, and so on. So all the decision, what the firewall is going to do with this packet is done here. And as we are monitoring this, we will see what's happening with this packet. And here we will see everything, what is happening. So it's packet at ingress stage, at the interface 1, 2, and the routing will say later on that the egress stage is 1, 1. This is the routing decision is needed for finding the right security rule and NAT rule. And then the match on the security rule is done. The match on the NAT rule is done. And here it's documented so we can read it. This is the security rule, which is matched. The source egress outside rule is matched. The NAT rule is source equal outside same name is matched. Everything is good. Source NAT translation will be done. That's what we have seen in the packet capturing write. There's no PBF rule, something like this. And firewall says everything is great. So there's no block or drop here. The firewall stage says everything is good with this tool. Huh? So why is it dropped? Okay, let's go further. So next thing we see is that really the same packet now is received as fast path stage. So now the packet will be handled, processed, and transmitted. So let's see what's happening here. So now, having this packet here, have a look. It's the type 8 code 0. It's an echo request, fast path. NAT session is running, translation is running, everything is done. So now we are doing a route lookup with the decision, what is the next hop? Not only what is the outgoing zone, so what is the next hop? And this is happening here. We will see our next hop. It's this IP address, okay, resolve ARP for this IP because yeah, the firewall is located in the same network. So I do an ARP request on this for this IP, and then ARP pending, packet drop, no ARP. So this is how we learn why this packet is not forwarded. The firewall wants to forward the packet to the next hop, but the firewall seems not to be able to connect to to get an ARP address, a MAC address for the next hop. So it seems that the next hop is not there. And this is something which helps me a lot when something else is going wrong. But the firewall is dropping the packet. Of course, the firewall has to drop the packet because the firewall is not able to forward the packet to the next hop because the next hop is not there. And this is something we will see with this flow basic. And I know, even though it's a little bit complicated to use the CLI to set this flow basic up, but if a customer is calling and we both do not understand why the firewall is dropping a packet, this tool is there for you, helping you to understand why the packet is dropped. So now time is already up, but this is what I wanted to show to just give you an impression that we have a lot of great tools on the firewall and the CLI, which are helping you if something is going wrong. And it's not only helping you if something is going wrong, it helps you to understand how the firewall is working. And these are some features we are doing in our 330 troubleshooting training. We just wanted to understand how the firewall is working and how we can troubleshoot stuff which is not working. And by understanding the stuff with the ingress, slow path, and fast path stage, how sessions are written into the session browser and not, we understand, this helps us to understand why something is not working. Okay, yeah, so I'm hurrying up because I'm already over time and I just want to be clear on the time. So just for documentation, I've documented the commands you need for the flow basic logs in the presentation. We will send the presentation to you after the session, so you will have them on the presentation. So maybe it's helpful to write them down so you can copy them in case you need them. And yeah, that's what I wanted to show you in this short session. Sorry, I hope it was not too much, but I'm always happy with all those tools and I want to share all this stuff. So I hope yeah, you get some information and maybe you're having some last questions.
Yes, one appeared a few minutes ago. It's regarding the PCAP and different stages. Maybe you can have a look at this question.
Ah, okay, yeah. The middle one, yeah.
Yeah.
In case, for example, we could see packets arriving in the receive stage and the drop stage, but not in file doesn't mean the packet is not being dropped by firewall policy. What could then be dropping the packet? Ah, so in case we had this example here when I said, okay, sometimes the receive stage is already dropping packets without sending into firewall stage. So there are some situations where we see packets in receive stage and in drop stage, but not in firewall stage. I think this is what the question is. And therefore, we have to understand what is happening. What is happening here in ingress stage, because this is more or less the same than receive stage. And this is what we are looking at in the training class, but I want to share this with you just a second. Yeah, there's a pretty nice knowledge base article, which is called Packet Flow Sequence in PAN-OS. And this is something day in the life of a packet, which is really interesting. If you have 1 hour time, have a look at this one. I will write this in the documentation as well in the presentation that you have the link. And here later on, you will see the different stages. And the receive stage is more or less something like the ingress stage we see here. And what the firewall is doing here is already doing some checks on the received packet. We are checking the IP packet. Maybe the IP packet is not correct. It's not a RFC conform packet, IP packet, how a IP packet should look like. So like the IP header might be larger than 20 bytes, which is not normal, which is okay with some options, but we should not use them anymore. And if somebody is using those options, we can already drop the packets because of this. Or if the packet arrives on the wrong zone, so if we have a source IP which shouldn't arrive at this interface because of the routing information, then the receive stage is already able to drop the packet. Something like this. Maybe we have fragments which are not correct and so on. So there are some checks which will be done already on the receive stage, which can lead to a drop of the packet. So this is explained here, the different tests on the different stages, like the ingress, the receive stage. So maybe the interface and zone lookup is not correct for the incoming IP packet. Then the packet is being discarded. So you would see this packet which is discarded on this decision in the drop stage and the receive stage, but not in the firewall stage. Yeah, I hope this answers your problem and your question, sorry. Good one, because this, have a look at this document. It's really, really nice. This is where we walk through in the training as well to understand, and we have some more examples to see what's happening. Okay, so packet passing, here you will see all the stuff that's happening on the different stages. Okay, I will put this link into the PowerPoint presentation so you can have a look at it. Okay, any more questions from you? Okay, cool. Okay, so we are already over time. If there are no one question, thanks to you as well. Thanks, everybody. So I think with this, we can close the session. The session is recorded as well. We will send the link as well in the mail we will send afterwards. There you will get all the information. I hope you enjoyed the stuff. If you have requests for other topics you want to see in such short 1.5 hour sessions, online sessions, just write us. We will try to realize this if this is for interest for many for some of you. Just give us some hints what would be interesting for you. Hopefully this one was interesting. And yeah, therefore, I would like to wish you a good lunch. And then after some hours later, have a great weekend, hopefully with good weather, enjoying starting the summer. And hopefully we see you soon on this, on some online courses or somewhere else. Okay, thanks so much. Or maybe in the trainings, huh? Okay. Thanks so much. Have a good weekend. See you soon.
Thank you. Merci allen. Habt ein ganz schönes Wochenende.
Okay. Thanks so much. Bye bye.
Bye. Tschüss.